Okay, and we're live. Welcome back to my attempt to learn how to make a roguelike in Rust by using this roguelike tutorial called Roguelike Tutorial, appropriately enough. And it uses something called specs, which I haven't quite learned yet. We're using it, but we don't know the details behind it or how it works, or what things like the difference between read expect and read storage, and how to go about finding the things that you're interested in. For example, here in this MonsterAI system, we're setting our system to need a point, a viewshed, and a monster, but then we only loop over viewsheds and monsters and use the point as the player position. We're not quite at the full grasp of how all of that works yet. But last time, on day 9, we finished up this quiet monsters until they see you. I lost my console. Someday I'll remember the... oops, failed to load resource. Oh, is this... No, this is running. Oh, fave icon. Okay, I don't care about fave icon. The monster shouts insults, because the monster can see me, but they only shout insult when I move. If I move here, boom, it shouted another insult. And if I go down and he can't see me, then he doesn't shout any. You notice the number here, 2, stays at 2. But as soon as he can see me, then suddenly the number goes up. So right now, the monsters shout insults, but they don't have the ability to move yet. So we have ogres with an O and goblins with a G. So that's where we are. We did that, and now it says differentiating our monsters. Monsters should have names, so we know who is yelling at us. So we create a new component name. In components RS, we add a name. So we're going to add names to our monsters. Let's do that. So this is where we left off last time. I use Mercurial all the time. So let's do this. Git log. Monsters only shout insults when they can see the player, and only run systems after player. So this is what we did last time, September 29th. So let's look at this. So we're going to give monsters names. Source lib components. We're going to add a new derived component. They keep adding debug, I guess, for printing things out, but I'm not going to add that until we actually need it. Struct name, pub name string. I keep doing that too with the semicolon. We register it in main, right? As you do. Source main. So we're gonna copy paste, change it to name, and then we're done. We'll also add some commands to add names to our monsters and the player. So monster spawner now looks like this. So where do we spawn the monsters? This is the player spawner. This is the monster spawner. And what we had here before was we're setting the glyph to G or O, but now we need a name as well. So I like to refactor the code as I go along, so it doesn't look exactly like it is in the tutorial. And it helps me make sure that I'm understanding what the code is supposed to do. So I'm going to do the same thing here, where we return a tuple with the glyph in the name. We'll do that here and here. So this is a goblin toString, right? ToString tuple, and then work ToString, right? And then we're going to add the name to the monster. So with name, the name being format name and I. Oh. So where do we get I from? Because we're going for each room. Oh, they switched this to enumerate. Okay. That makes sense. Let's do that. For I, comma, room. Skip one, enumerate. Right, what other changes are in here? We got the view shed, we got the monster, we got the name, we build. And now we adjust the MonsterAI system to include the monster's name. Okay. Source lib MonsterAI system. So we have struct MonsterAI, we still have this. The system data now takes the name as well from read storage. Name. Right? And we get player pause, view shed, monster, and name. Data. We add name here. And we add, that's interesting. So we're getting some shadowing going on, right? Because we have a name. This name matches this name. But this name is from the component that's part of the entity that has a view shed, a monster, and a name. And then we use here name.name. So it's a lot of naming going around. So console log, we're going to change this to format monster name shouts insults name.name. Okay, and we need to pull a name here. And probably I need to add it to main. I don't remember if I do it individually here. No, I just do tutorial star. So that should pull in everything from, that should pull in the name from the components because our mod thing just pulls in everything from components. All right. Does this build? It does not. Oh. No, semicolon. Oh, I forgot the second closing parentheses. All right, let's do that. Build. Oh, that's even worse. What did I miss here? Oh, again, I missed that on line 49. First main. 49. Add a close. Does this build? Does not. Expected U16 found struct string. Oh, because I got these backwards. Glyph. Does this build? Good. Okay. And now let's see if we have individual monster names. So I hit refresh. And we found a monster. Goblin number 2 shouts insults. Okay. He's shouting insults as long as he can see me. And if we go to a different room, we have goblin number 3. Are there any rooms where I can see 2 monsters at the same time? Oh, look at that. Orc 0 and Orc 1 are both shouting insults. Very cool. Alright, so that was giving monsters individual names. Oh, yeah, they show it down here. Neat. All right, let's check that out. Oh, that's a wrap for chapter 6. Okay. Oh, cargo format and cargo clippy. I should really make that part of my build. Get diff. What do we got? So we added the name component. We added the name to our the data we're reading in our MonsterAI system, and we changed the insult in player. Oh, in player cargo format deleted a blank line for us. Very good. We added we sorted those. We added name to the registered types of components, and then we created names for our goblins and orcs, and then we generated a unique name for each goblin and orc. Okay. That's all. Git commit. Monsters now have unique names. Oop, forgot the add. There. All right, so good. Chapter 6 is done. Chapter 6 is the same thing as 2.5. All right, it only took us 10 minutes. Let's take a look at dealing damage and taking some. All right, now that we have monsters, we want them to be more interesting than just yelling at you on the console. This chapter will make them chase you and introduce some basic game stats to let you fight your way through the hordes. All right, so chasing the player. The first thing we need to do is finish implementing base map for our map class. In particular, we need to support get available exits, which is used by the pathfinding. In our map implementation, we'll need a helper function. Is exit valid? So this is taking an XY and returning true or false. If X is less than 1 or width minus 1, or so if it's off the map, return false. Otherwise, we will look to see if it has a wall. And if it has a wall, then we return false. If it doesn't have a wall, we return true. Okay, so it's just checking to see if it's a valid place to move to. I'm not sure what exit means in that context. Maybe exit from my current square. So in our map implementation, we need a helper function. Okay, so this. Is exit valid? Self x I32 y I32, returning a bool. If x is less than 1, x is greater than self width minus 1, y is less than 1, or y is greater than self height minus 1, return false. Otherwise, we will grab the index self xy idx xy and return whether or not. See, IDX is usize. I think I'm returning a usize from XY IDX. Yeah, so I don't need to do that as a usize business. Not equal to tile type wall. Just like that. Okay? This takes an index and calculates if it can be entered. All right, is exit valid? Can it be entered? We then implement the trait using this helper, get available exits. Okay. We're implementing the trait using this helper. So this is another helper. So this also goes in the map struct implementation, right? So this implementing map, exit valid, we'll do fn get available exits. Self and IDX of usize. Returns an RLTK small vec usize F32 10. Okay. Oh, I missed that. So it's taking it's a small vec, it's a size 10 vec of tuples of usize and F32s. And that's what we're pushing here onto the exits. Let mute exits, RLTK small vec new. We're only pushing 4, up to 4, but we're looking for 10. I guess when we do diagonals. Alright, not going to worry about it. Let mut exits equal to RLTK small vec new. Let x equal IDX as I32 self width. Let y equal IDX as I32 divided by self width. See, this is, isn't this, okay, this is destructuring the get xy IDX. Let w equals self width as usize. What is self width? It's, oh, these are our I32s. Okay. All right. if self.isExit valid x minus 1 comma y, then exits.push id x minus 1 1.0. And I assume that this is the distance. The 1.0 is the distance. I don't know. They didn't explain what small vec was or why it's a thing. Anyway, I'm going to put a semicolon there. X minus 1, x plus 1, idx minus 1, idx plus 1, and then we do the same thing for y here. Y minus 1, y plus 1, and then this changes to idx minus w and oops, why did I type 2? Idx plus w. All right. So this is, it's saying if it's okay to go to that XY location, right, then add it to the list of exits that it's okay to go to. And then we return exits. All right. And now we implement something called getPathing distance in our base map implementation. But we're not actually using, where are we using the helper functions? This is used here, right? But who's using this? Is it down here? A star search, XY index. Then implement this trait using this helper. Providing exit without a distance heuristic will lead to some horrible behavior, so also implement that for your map. Should this go in base map? I'm puzzled. Okay, let me in map RS's get available exits function we had, oh, that's for diagonal movement. I'm jumping ahead here. Okay, so yeah, so maybe this goes in the map, implement base map for map. It doesn't say to do that explicitly, but it's got to be, right? Where else is it? Where else would it go? How else is it called? So let's do that. Let's put that in base map. And then I had a double blank line somewhere along here. Yep. Right there. Okay, and then, so let's get available exits. And then get pathing distance. Okay. Self idx1 and idx2. So this is returning the distance between two different points. W equals self width, right, as usize. Let p1 equals point new. idx1 mod w, idx1 divided by w. Let p2 equals point new, idx2, idx2, and rltk distance alg Pythagoras distance 2d p1 p2. This is probably just, you know, a square root of the distance, the sum of the squares for the distance. Standard 2D distance calculation, and then Okay, yeah, pretty straightforward. Hopefully this is right. Hopefully the get available exits belongs in here. And then we evaluate each possible exit and add it to the exits vector if it can be taken, and then we get this pathing distance thing here. All right. And then in MonsterAI system, okay, let's go over there. Right? We're going to expand this guy. So we currently have point, viewshed, monster, name, and now we're going to add map, right expect map, and point and viewshed and monster and name, and now we're going to add position, right storage decay position. Right? And then we put a space there. If function run, and we're going to add these guys, mute map, player pause. We're going to mutable viewshed. This says reach. Oh, they changed it to right storage. Okay. So viewshed, monster, name, and then position is equal to data. All right, I'll let Cargo format that for me. And then we're going to mute viewshed, monster, name, and position. And a mutable borrow there, monster, name, and position. All right. So if viewshed visible tile contains player pause, we shout the insults, and then we look at the path to the player. Right? Let path RLTK a star search XY ID X pause Y as I32 XY ID X player pause X player pause Y. It would be nice if we had a version of this that took a point. That's I32. Okay, and that gives us our path. Not sure what that returns. If path.success. All right, so a star search says whether or not it worked, and the path steps len is greater than 1. How many steps it takes to get to from position A to position B is more than 1, so we're not on the player, I guess. Steps 1 as I32 map width. Be nice to have helper functions for these guys as well, right? Because we seem to be doing this a lot, mod and div. And then, oops, viewshed dirty is true. Boom, 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 boom. Okay. We're not actually checking the, oh, in the viewshed, maybe that's in the viewshed code, which is generic over all entities that have a viewshed. Let me just check the visibility system here. Yeah, so every entity, so we loop over every entity that has a viewshed in position, and if the viewshed's dirty, then we regenerate the viewshed. So here we're saying we're modifying the position of the monster. Right? We got a mutable position for the monster. Every monster has a viewshed and a name and a position gets looped over. And we modify the position of the monster based on the A star search to the player. Okay, and then we set viewshed dirty to true, saying we have to recalculate the viewshed for this monster. If we've changed a few things to allow write access, requested access to the map, we've also added an allow to tell the linter that we really did mean to use quite so much in one type. Well, let's see if Clippy still complains. The meat is the A star search call, RLTK includes a high-performance A-star implementation, so we're asking it for a path from the monster's position to the player. Then we check that the path succeeded and has more than 2 steps. Step 0 is always the current location. It's more than 1 step here. Okay. If it does, then we move the monster to that point and set their viewshed to be dirty. So let's try building this. And it failed. Oh, no, I don't think it's because of the not found in the scope, not found in the scope. Okay, so we just have to add map and position to the MonsterAI system, right? Map, position. Yeah, okay, and then does Clippy complain about the type? Clippy complains about the type. Oh, and then apparently we have a mutable map and we don't need a mutable map. Okay. Well, first let's see if this works. Do monsters move towards me as I move around the map? Ooh, look at that. Oh, we got stuck in the corner. There we go. There we go. Look at that. Now he follows me everywhere. Run away, run away. Don't forget. Oh, I bet you he's on top of me now. Yeah, you can see the very faint, I don't know if you can see it on through the Twitch encoder, but there's a very faint G, very brief G underneath me just as I move off that square, and then the monster moves on top of me. All right. Goblin has been shouting insults this whole entire time as he stands underneath me. So that works, but let's fix this. And I think I don't like doing this sort of thing. But I think if you make it an actual type rather than a trait type, a source lib MonsterAI, oops, MonsterAI system. I think if you just make it a regular type, right? If we take this all out and just make it an actual type, and we'll call it MonsterAI data. It'll need a lifetime to support all these lifetimes, and then we can just say type system data is equal to MonsterAI data, right? I think we can just do that. Oh, I typoed it there. MonsterAI data. Will this work? I think we can do that. It builds. What does Clippy think? Right, so okay, so it's not complaining about the type anymore. But we can take away the mutability on the map. Let's change that to read expect. We don't need the map to be mutable. That's interesting. So we're passing in a mutable reference to a map. And it's saying A-star search doesn't need a mutable mutable reference. So let's see. No. Trait base map is not implemented for specs. Oh, do I have to do the star? Yeah. Star ampersand. Dereference it and then reference it. Okay, that built. And then Clippy's happy. Clippy's happy. Look at that. Alright, so what do we do? Right, we've changed a few things to allow write access, requested access to the map. We've also added that. Yeah, so I fixed it differently. Monsters will now chase the player and stop if they lose line of sight. We're not preventing monsters from standing on each other or you, and we're not having them do anything other than yell at your console, but it's a good start. It wasn't too hard to get chase mechanics in. Okay, good. Good. So what do we do here? We got, we're checking exit is valid. We have this thing get available exits, which allows us to check the 4 cardinal directions. We have to still add diagonals. Get pathing distance. Use the 2D distance algorithm that Pythagoras invented eons ago. And then we modified this system data because it's getting big, so we pulled it out. And then we've got map, player, pause. We extended the data here. We're looping over everything that has a viewshed, a monster, a name, and a position. Every entity has all 4 of these components defined. We do a star search towards the player's position. And if we found a path to the player, then we change our position and change our viewshed to be dirty so that we recalculate whether or not we can see the player. Wow, that's pretty good. All right, so 2 things accomplished, and then next time we will look at blocking access. But for now, get add source, get status, right? Get commit. Monsters can now follow you and chase you. All right, we will leave it there. Thank you very much for watching. Let me transition to my closing slide. And I hope to see you soon. Take care.